Hi there, this is Katie Kimberling with TutorPUG, and this is a quick video on how to do a future value problem or a present value problem for Business Calculus 2. So when you're doing these, please note you will need to know both of these formulas. They are both antiderivatives. Both of them have a 0 on the bottom and a capital T on the top, which represents the length of time that will elapse for this particular amount of money or investment to be invested. They both have a function called R of T, which is called the flow rate function, and you will be responsible for creating that. That might be, if there's a tricky part, that might be the tricky part to this, is you have to construct this with clues from the written problem. They both have an E, and then the only thing that's different between the two formulas is the exponent on the E. So over here on future value, we have little r, which is the investment rate or what the invested money is earning. That's what the bank is giving. Sometimes it's called the APR or the nominal rate. This guy uses big T a second time. So again, that's going to be the same value as this big T. And this one subtracts little t. Now on these problems, you're going to plug stuff in for R of t. You'll plug a number in for big T. You'll plug a number in for R. You'll plug a number in for big T. You will not plug anything in for little t on either one. That's your variable. It's like your X. So if you're doing these on the calculator or if you're doing them by hand, this will remain little t, which is your variable. There are the notes for Bob and Susie. So on the birth of their child, Bob and Susie plan to invest 3% of their combined weekly income of $2,250 over the course of this child's life. They're going to invest it into an annuity that is earning or bearing 3.96% interest. They expect that their salaries are going to increase over time, so they're doing a good job, and they think that it's going to increase at a rate of 3% per year. And we want to know how much is going to be in the account for the child to go to college after 18 years. This is a future value problem because we're going to wait 18 years. We're going to continuously put money into the account over 18 years. And then when the child is 18 years, they're going to go to the bank and say how much is in there. Ta-da, yay, great, let's go to college. So when we're constructing the R of T, and it doesn't matter if you're doing future value or present value, R of T is going to operate the same way. You're going to ask yourself 4 questions. Ask and answer 4 questions based on the problem. Sometimes the answers to the questions are, yes, move on, or we don't need to worry about that, or just put a 1 in that blank. But it's very important that we ask ourselves 4 questions and make sure that they are all accounted for. When you're constructing the flow rate equation, these are the 4 questions that you need to ask yourself. And we're going to walk through this using the Bob and Susie example. So the first blank will always be filled in for any flow rate equation. The rest of the 3 might not have anything in them, but the first blank the question will always be answered and it will always have something in there. So the first question says, show me the money. How much money do we have available to invest? So whether it's Bob and Susie investing some of their income, or whether it's a major corporation investing last quarter's revenue or last quarter's profits, so we're investing money. So here, you're going to read the problem and look for the dollar sign. So in this example, Bob and Susie have $2,250 to invest. They were just going to look for the dollar sign. Don't worry about anything else right now. They're going to invest $2,250. So that will always be something that gets filled in. Then we have to say, is that for a year? So they're making $2,250, but we have to figure out, does that represent an annual amount? Because that's how the flow rate equation works. The money that we enter is always converted to an annual amount. For Bob and Susie, $2,250 does not represent an annual income. It represents a weekly income. So combined, they're making this much per week. So we have to convert that to an annual amount. Well, it's very simple. There's 52 weeks in a year. So I'm just going to do 2250 times 52. If this was a major corporation investing last quarter's profits, I would put the dollar amount of their profit, and then I would multiply by 4, because that would represent quarterly converted to annually. The third question is, how much of this money are Bob and Susie dumping into the account? So if they're going to invest for their child's future, they're not going to invest 100% of their money, because if they do, there's not going to be much of a kid left to go to college because they forgot to feed it and they had no lights and electricity and running water. So they're only investing a portion of their income, and the problem says that they are going to invest 3% of their combined weekly income. So how much is invested? This is going to be 0.03, representing 3% of their income. If the major corporation was going to invest all of last quarter's profits, I would put how much their profit was times 4, and this I would either leave blank, or you could put a 1 in there for 100% to represent all of that money being invested. The fourth question, I call it, are you good at your job? And what this means is sometimes in the problem, there is an expectation or a written down part that says this available money over the course of the investment will either increase or decrease. And it could either increase by a constant amount every year. So maybe the major corporation thinks that their profits are going to increase by $1 million per year. That would be a constant amount. Or it could be a percentage. Maybe you're getting a cost of living % increase, or just it's built into your contract that you get an extra 2% every year just for showing up and doing your job. This blank is probably the one that is filled out the least, but it can be. And in this problem, Bob and Susie expect, their salary, their combined salary, to increase by 3% per year. So since we have a percent increase, they're good at their job. This blank is going to be filled in with 1 plus the percent increase raised to the t, because that's per year. If they expected that they were going to get decreases in their salary every year, sometimes that happens with major corporations. They expect revenue to decrease. If I have a percent decrease, I would do 1 minus that amount, again raised to the t. So I'm not going to actually put that written down into this blank. I'm going to do that math. So since Bob and Susie have a percent increase, I put 1.03 to the t in that blank. If they were getting a percent decrease, I would put 0.97 to the t in that blank. So all of that is just R of t. Now I'm ready to calculate their future value using the R of t and then all of the other components in the formula. So the future value of this money, which means what's going to be in the bank when they go back and pick it up after 18 years, is 0 on the bottom, 18 on the top. And now I'm going to write my flow rate equation. And just so I don't get into any algebraic trouble, I'm going to write every single individual piece and not worry about multiplying things together. The calculator can do that for me. So I have 2250 times 52 times 0.03 times 1.03 to the t, and all of that is just this R of t. Now I'm ready to get into what the bank is going to give them. So I add on my little e. The interest rate that the annuity is bearing is 0.0396, 3.96%, and I'll move my decimal. Now I do 18 minus t dt. So now I'm ready to go to my calculator, and I hit y1 or y equals, and I enter all of this into y1 using parentheses, and the only thing that's different in my calculator is instead of the letter t, I have the letter x as my variable. And then I go to my home screen and I hit Math 9, and I'm allowed to enter this into my calculator. That's what Math 9 looks like. So that says antiderive from 0 to 18, the equation that I put into y1, which is all of that, with respect to x. So when I hit enter, I get 117893.04. On these problems, the units will always be some form of money. What I mean by that is it could be $1 billion or $1 million, but this part of the formula represents their annual salary in dollars. So my final answer is $117,893.04, which is what will be into the account when Bob and Susie go back to check on how much is in there after 18 years. If I wanted to know just the portion that Bob and Susie had invested, that's called the principal. So what had they contributed over 18 years? Then I would just antiderive the flow rate equation. So if I want to know just what Bob and Susie contributed, what did they invest from their own pocket over the 18 years, I am just going to antiderive the flow rate that we constructed. And I'm not going to tack on that portion of the equation, because that represents what the annuity contributes, or what the bank is contributing, or what the investment is contributing. If I just antiderive the flow rate equation, that tells me what portion of their total investment was just money that they saved and contributed. So out of that $117,000 that they got at the end of 18 years, they actually contributed $83,000 out of their own pockets over time. That is a discussion of how future value works. Practice these. I've put a link to some practice problems in the show notes, and happy mathing.